Einstein's equations, let's take the case without any matter, no energy momentum tensor. Then the equations of motion are just r mu nu minus 1/2 g mu nu r is equal to 0. That's called the Einstein tensor, g mu nu equals 0. And it can be simplified. If you take the trace of both sides, the r here is the trace of the Ricci tensor. If you take the trace of both sides, you will discover that r, the scalar curvature r, is equal to 0. And once you know that, you can ignore the second term in the equation. The equation is simpler. That doesn't really matter because we're not going to write down the details anyway. But this is the equation of Einstein in a context in which there is no energy momentum tensor on the right-hand side. All right, what's an equilibrium situation? An equilibrium situation, first of all, means a solution which has no time dependence. There's really, and which also doesn't have any matter on the right-hand side. Matter is another word for the energy momentum tensor on the right-hand side. No right-hand side. There's really only one equilibrium situation. The equilibrium situation is just empty space. Empty space is time independent. The by empty space, I mean empty flat space. No curvature, no interesting gravitational field. And in that case, the metric, g mu nu. Now, I'm not going to say the metric is equal to such and such. The metric depends on the coordinates you use.